So we are now on the next chapter, no, or next module, module 2. That is rectilinear translation. And let's start with the first lesson. That is rectilinear motion with constant acceleration. So by the end of this lesson, you'll be able to understand first the characteristics of rectilinear translation and also the definition of rectilinear. So what is the meaning of rectilinear? Second, you will be able to understand the concept of free falling bodies. So these are bodies that falls due to the influence of gravity. And of course, we will talk more about this topic. And then lastly, you will be able to apply the kinematic equations in solving problems relating to rectilinear motion with constant acceleration. So the third learning outcome is the main highlight for this meeting. So we're going to derive these kinematic equations. So we have 3. Okay. So what is rectilinear translation? Let's start with this word, no? Kaning rectilinear. When we say rectilinear, the path of our motion is straight. Okay? Straight ang iya path. Whereas the opposite of rectilinear, which is also part of our discussion for dynamics, we also call that one as curvilinear. No? Wherein its path is not straight but curved. Okay? Again, when we say rectilinear, the path of travel by our particle or body is straight. Okay. Now, let's talk about translation. So in the first figure right here, when we say translation, no, this is a motion of a rigid body. As you can see in this figure, we have this rigid body shaped in oval, no, oblong siya. So translation siya if this body no moves, no, so ang kanisiyang this figure on the right, no, nga naka-hidden, naka-broken line siya, mo na siya iyang pag-move. Ma-translation lang siya if we draw a straight line passing through any points of its particles. Say for example, this oval, we have 2 particles here, this one and the second. Okay, if we draw a straight line, no, if we draw a straight line, and then if this particle or if this body, rigid body moves, if it moves, then we also track the particles that we've mentioned. So naadre si 1 mo na iyahang new position, and also this particle number 2, this is now its new position. If we compare the orientation of the rigid body before and after it travels, we notice that this straight line, no, this straight line number 1 and straight line number 2, they are parallel to each other. Now, if that happens, or if that is the case, then we can say that this oval shape translate or travels, no, according to this statement. Okay, or in other words, when we say translation, just a line, no, the path of travel is a line, so it could be a straight line or a curved line. The opposite of translation, we will discuss that one later, is rotation, wherein the rotation is that is the movement of a body with respect to an axis. Okay, for translation, we don't have a reference axis here, because as we map the particles at every point during its journey, we can say that we can create a straight lines, no, that are parallel to each other. On the next picture, no, so This is one of the characteristics of a rectilinear translation, wherein the same um object, we have here an oval, and then we have here our first particle, second particle. So at this particular moment, no, assuming that this oval moves, of course, the first particle has a velocity. Let's say this is v1 and then v2. So by its characteristic, no, all particles now comprising the rigid body have the same values. So meaning v1 should be equal to v2. Meaning on any parts of this oval, no, they have the same velocity regardless of their position, no, regardless of their position within the object, okay, or within this oval. Bisag napa na siya sa babaw, napa na siya sa ubos, or closer ba siya sa center of gravity or at the centroid, they all have the same values for their velocities, displacement, and acceleration. And then if this one translate to another location, or if this one moves, so mao na po di ang particle 1, particle 2, given that let's say this oval accelerates, so another value for its v1, ato na siya denote as v1 prime, and of course this v2 prime. Still, by its characteristic, or by this rule, we can say that v1 prime is still equal to v2 prime. Now, if this is the case, no, if this is the case that all particles that comprises this oval have the same velocity, then let's just represent, no, let's just represent this rigid body as a single particle. This is the final statement, no, final statement for the characteristic of rectilinear translation, wherein we just select a single particle. So the selected particle to be used during motion analysis, since our target here is we're going to analyze the motion of a rigid body, no, for kinematics, let's select only one particle that will represent a body or a rigid body, and that, I mean, the location of that particle should be at the center of gravity of the body or the object. So this particle right here, its location is at the center of gravity. Okay, this information is already enough because from the previous statements, or from the previous pictures ang ipakita sa inyo, ha, we say nga at any point, no, at any point on the oval or on this object, they have the same velocity, displacement, and acceleration. So that is why we just represent a single particle for this rigid body. So nakasunod ra? Naay question? Wala. So next, I will going to show to you the derivation of the three kinematic equations. So we have three kinematic equations, and this is an essential part, no, in motion analysis. So it can be derived using either physical principles from your physics class and also by differential equations. Now let's have a recap sa inyong physics nga class. Kuan ba mo? Gi-show ba ang derivation for these three kinematic equations? Nag-discuss mo ani, class? Hello? So wala gid gi-derive. Okay, given na. Mas mayan to i-derive. Anyways, the derivation that I will going to show to you is by the use of differential equations. So nabo mo differential equations karon or humana mo ani? Okay, karon. So kay baho na mo unsay differential equation? Gamay, sige ato na padak-on. So when we say differential equation, these are equations that contains differential coefficients or differential terms like the mga dy, dx, something like that. So in the previous discussion, no, if you already watched the first chapter for dynamics, I've discussed there the formulas for the instantaneous velocity, instantaneous acceleration. So first, no, since this lesson talks about the rectilinear motion with constant acceleration. So we assume here that, okay, assume A or the acceleration should be not zero but any value. So constant lang. A is constant. Now, since we are using differential equation, so we must find an equation that relates acceleration to the rest of the parameters. Remember, in deriving these equations, always note the parameters, useful parameters. First, we have displacement, x, velocity, v, acceleration, and time. That is x vat, in short, x vat. So, the available equation that relates acceleration with velocity and time, we already know that one, that the instantaneous acceleration A is equal to the change in velocity, or that is derivative of the velocity over the derivative of time. Here, we are going um, to come up, no, to come up an equation that relates acceleration, velocity, and time. However, we cannot have this equation. Why? Because this equation contains differential terms. That is why this is an example of a differential equation, very famous differential equation nga naa sa mathematics, nasa physics, and even in engineering mechanics. So we're going to cross multiply this one. No? So we have derivative of velocity equals acceleration times the derivative of time. Now, acceleration here is constant. So no other parameters nga complex. So integrate directly. Okay? This is a variable separable nga method in solving differential equation. So integrating both sides, and then we assume that in our derivation, let's start from initial velocity. Let's denote initial velocity as v naught to the final velocity, that is v. And also with respect to times, that is initial time t naught to the final time t. However, in most problems, no, most problems, the time reference is zero. Let's say 0 seconds. So therefore, our TO here atuloy assume as 0. Okay? So, syaro, murag sa integral, wala na siguro problema. Kaya nakaagi na mo. So, integral of the derivative of v is simply velocity v. Okay? So, evaluated at initial to final is equal. Now, a here is constant. So, i-factor out na siya. And then, the integral of time is just, integral of derivative of t is just t. Okay, evaluated from 0 to the final time. Now here, we're going to simplify this. So final velocity minus initial velocity equals acceleration times the time only. No need to write 0 kay 0 maghapon. Now rearranging this one, so therefore we have our first kinematic equation wherein it relates that the final velocity is equal to the initial velocity plus the product of acceleration times the time. So this is our first kinematic equation. Okay? So if ever during motion analysis, or if ever na mga problems that the given are the initial and final velocity and also the acceleration, then we can solve directly the time. So second is we need to find another differential equation na pod, and let's see if we can have a relationship that exists between between the four parameters, because in a certain kinematic equation we need at least four parameters, just like the first one. Okay, we only have we have here final velocity, initial velocity, acceleration, and time. So for the second, let's relate velocity or initial velocity, displacement, because we haven't include the displacement yet in our kinematic equation, and also acceleration and time. Okay, so upat. Now the next thing, since we are already through with the acceleration, now let's proceed to velocity. We all know that velocity, or the instantaneous velocity, is equal to the change in displacement over change in time. This one is another differential equation. So cross multiply, we have dx equals final velocity times dt. Now we cannot treat final velocity as a constant because it would vary, no? It would vary. It depends upon the other parameters. But luckily, we already have an equation for final velocity, no? This one right here that we have just derived. So we can substitute this one. So we have derivative of x, okay, is equal to v naught plus at tapos dt. The next step is we're going to integrate. So integrate, that is from the initial displacement towards the final, and then this one is from 0 to the final time t. Now integrating this one, so since this is the x alone, so x na siya, evaluated from initial displacement to final displacement. This one right here, ato pang distribute, no? So from 0 to t, we have v naught, and then this is dt plus a integral 0 to t, and that is t dt. Okay, so this one, v naught is constant. So v naught is constant, given na siya, no? Unlike this one, the v here is very variable, no? So we can extract v naught here. So if we're going to simplify this integral, then it would become v naught t, so evaluated from 0 to the final final time, plus a. Now apply power rule here kay t dt. So applying power rule, that is t square all over 2 from 0 to t. Simplifying, so we have here x minus x naught is equal to v naught t, okay, wala na siya yung minus v naught times 0, okay, automatic 0, plus that is 1 half a, and then evaluated at t, so that is t square. Now in some books, no, they compress x minus x naught, because x minus x naught can be represented by delta x, or the change in displacement. So therefore delta x is equal to the initial velocity times the time plus 1 half a, and then t square. This is our second kinematic equation. Okay, any question so far? Okay, wala na. So don't forget that the initial velocity, the displacement, and the acceleration, these three are vectors. So be careful sa ilahang mga signs because the sign will tell their respective directions. Now for number 3, we're going to relate again. So let's write again the important parameters: v naught, v, x, a, t. So let's try to relate final velocity, initial velocity, acceleration, and displacement. Meaning, wala na time, no? Wala time. So, asa po tayo mangita? Now, we all know that acceleration is equal to dv over dt. And we also know that velocity, instantaneous velocity, is dx over dt. Now, we can combine these two differential equations and eliminate dt. Okay, so in the first differential equation, dt is dv over a, and in the second, we have dt is equals to dx over v. Now, equate the two equations. So we have dv over a equals dx over v. So this is a variable separable wherein let's combine the differential coefficient to its corresponding variable. So since dv mo match siya ni v. Now don't worry for a, even though wala siya dA, because a here is constant. So cross multiply, we have v dv equals a dx. In other words, combine those expression that has the same variable. For dv, so v siya. Don't worry for a, bisag asa na siya butang, okay na siya because that is constant. Afterwards, so perform integration. So integral. So that is from initial velocity to final. Whereas here, initial displacement to final. Evaluating this one, let's apply power rule. So that is v square over 2 evaluated from initial velocity to final equals, the acceleration here is constant, so factor out or bring out, no, outside this integral sign. So a simply x, so that is from initial to final. Basig mag-wonder mo, wala lagi plus c, sir. So wala siya plus c because this is definite integral. Okay, next, let's simplify this one. So we have v final square all over 2 minus v initial square all over 2 is equal to a times x minus initial. Now factor out the 2, so we have v final square minus v initial square equals a, and since we already have another value or another representation for x minus x naught, that is delta x, so let's just write here delta x. So multiplying both sides by 2, so we have v final square minus v initial square is equal to 2a, change in the displacement. Then simplifying further, we have final velocity squared equals initial velocity squared plus 2a times the displacement. So this is our third and final kinematic equation. So let's try to list again, no? So first we have V equals V naught plus AT. Second one is the displacement. Okay, V naught T plus 1/2 AT square. Then the third one is this one. So V final square equals V initial square plus 2A delta X. So these are the three kinematic equations. Any question? Pangutana? Okay, wala. So let's proceed to the free falling motion. So free falling motion is an example of a rectilinear motion. So this type of motion is influenced by the gravitational acceleration of the Earth. So the kind of typical value of the acceleration due to gravity of the Earth, we already know that one, that is constant at some point or constant at sea level, that is 9.81 meter per second square in SI, and then 32.2 feet per second square in English or imperial units. This is the scenario for a free falling motion. So let's start at the ground, no? Even though the name itself is free falling, no? Kung imo na siya interpret, kana ra untang ato ihog, no? Ihog ang object. But why is it nga naay cases o naay problems nga ato ibagtak pa ibabaw? So appeal po na siya sa analysis. Under gyapon na siya sa free falling because there comes a time nga imo ilabay ang object pa itaas, mobalik gid na siya towards the ground. Okay? It will just reach its maximum kanang point. Now, in I mean, most pictures no nga mag-depict sa ato ang free falling motion is that it looks like a very kanang kitid kaayo siya nga parabola, no? So makaingon ta nga ang path di ay sa ato ang free falling motion is not a straight line but a curved line. However, the ideal condition is as long as the thrower is kanang proper iyang pagka-orient sa pag-throw niya. Actually, it will just fall to where it was thrown, no? Pero syempre di na mahitabo in the aerial scenario. It depends upon the thrower good, no? And also some other factors like the wind, no, the magnitude and direction of the wind, and other external forces. But for the purpose of visualizing free falling, so it start at the ground or at the thrower. It could be a man or a cannon, no depende. In our figure here, let's have this black ball. So this black ball is thrown with an initial velocity, no, v naught. So it goes upward, and since it is influenced by the Earth's gravitational acceleration, so ang iyang velocity will decrease. Mo nang moabot gid siya sa point nga mo zero na ang iyang velocity. And that kanang particular condition, the object or our black ball already reaches its maximum height. So this is our delta y max, the maximum height of our object. Okay? Kay, what if we are going to remove the acceleration due to gravity g? So if we throw an object upwards, of course, it will keep on moving upwards if ever there is no gravity. Okay? But since there is gravity, so its velocity will decrease as it moves upward and reaches its maximum height. At the maximum height, our velocity there is zero. Okay? Zero na siya. Kung ano man na ni kuan, wala naman na ni pader taas. So again, mo zero siya, and then from zero it would also fall. So why it falls? It's because it already possess a potential energy, and that potential energy is converted back into kinetic energy in a form of velocity. So it moves downward, and also with the aid of the Earth's acceleration, so it will propel downward. And then the velocity here, once it reaches the ground, is equal to the initial velocity, given that there is no air resistance. So the final velocity here is the negative of the initial velocity. So why negative, sir? It's because ang iyahang direction opposite from the initial velocity, but they have the same magnitude. So this is the representation, no, the visual representation of a free falling motion. Okay. Now, what are the equations uh, that will be used in free falling motion? So, ato ra gamiton, same ra gihapon sa atong mga na-derive kaganiha. Again, just a review for our kinematics for straight line motion. Mo na atong na-derive kaganiha. Velocity, final, we have here displacement, and also final velocity squared. Now, let's modify lang the other parameters, no? And match those one in free falling motion. Now, in free falling motion, for the first kinematic equation, the only difference here is the acceleration. So in free falling motion, the acceleration here is constant. Okay, that is why it belongs to this lesson, because free falling wala na laing acceleration nga naka-influence ana, but only the Earth's gravity. Okay, that is G. So that is why we have here G instead of A. And why is it nga minus sign? Minus sign, it's because let's assume that um, the acceleration due to gravity influences the velocity, or the direction of pull of the earth is opposite sa ato ang kanang path of travel. However, this is not final, no? There are some cases that we need to change this one into positive. Now, kung saan man ta mag-change na into positive. So, mo-change na ta ani if ever our direction of motion is in line to our um, direction of the Earth's gravity or the Earth's pull. So, asa may metabo kung paubos na ang ato ang tong object. Kung paubos siya, so this is our direction of motion, and also the direction of our gravity is pa downward pod, so therefore plus na siya dira. Okay, so for the displacement, uh, the parameters that changes, first is the representation of the displacement instead of x, because x used to represent horizontal motion, so we replace that one by y. Y represents vertical motion. So since free fall is vertical motion when I say so we use y. And for a, so still g negative. Let's assume nga this equation, assuming we throw an object upwards, so kahit man siya ang gravity kay pa-pull man downward, so therefore we have a minus sign here. However, if mo fall na siya, so pareha na silang direction ni gravity, that is now the time that you should put plus sign here. Okay, for the last kinematic equation, um, the only parameter that changes is the displacement, and all I mean the displacement and the acceleration. So as instead of a, use g, and still negative siya. Okay, because this equation is assumed that you throw an object upwards. Okay, when we throw an object upwards, our displacement there is positive, because naa siya sa positive y-axis. And for our g, common siya, opposite man iyahang direction sa Earth's pull, so therefore we have here negative. So always remember, general rule for free falling, the parameters y, the displacement, the velocity, and acceleration are to be taken as positive if, no, if ang direction of motion or in the direction of positive displacement. Okay? If positive gali ang direction of travel, then kuan pod siya, positive pod siya. Say for example, if paubos, no, paubos, then our acceleration is positive. It's because the direction of our acceleration due to gravity by the earth is incoherent or is equal to the direction of our motion. So mara na itigam eh. Now let's apply this one sa ato ang problems. So I have here three problems. So let's start with this first problem. A stone is thrown vertically into the air from a tower 100 feet high at the same instant that a second stone is thrown upward from the ground. The initial velocity of the first stone is 50 feet per second. The second stone is 75 feet per second. The question is, when and where will the stones be at the same height from the ground? So the requirement here is, when we talk about when, that is the time. And then where, so it talks about position or displacement. So since this is free falling because we throw two stones upward, so we use y here instead of x. Now, for this kind of problem, it is very important, no, to draw or to illustrate what happens to this problem so that you have a map, no, you have a guide in order for us to generate a or to generate the right kinematic equation. So I have already here the interpretation of this problem. So as you can see, we have here the tower represented by this graying block or box. I mean rectangle, sorry, rectangle. And then since we have here uh, two objects, stone, but since the stone, let's assume that the stone is very small compared to its path, so we assume that this stone is a particle rather than a body. So first stone, let's draw this right here. So the first stone is thrown upwards, represented by this delta y1 and also this arrow. And the second stone is nasa ground, gi-throw po siya upward. And both stones are thrown uh, at the same time. Okay? At the same time ba? Yes. So, gi-throw sila at the same time. Now, in in dealing with kinematic problems, just like this one, rectilinear translation with constant acceleration, no? It's okay if highlight mga assumptions, and of course, there are chances that our assumption is different from the result of our solution. So it's okay. Ang nagkalahi lang ana if na ay mistake sa assumption is that it could be the sign, no, or the direction of the velocity or the displacement or the acceleration. But that's not really a big deal, no, with regard to this kind of problem. So next, the first stone that is at the top of the tower, it has an initial velocity of 50 feet per second, represented by this one, v naught 1. And the second stone at the ground, v naught 2. Okay? So, i-assume na to nga, at some point, no, above the tower, let's say, nag-meet na sila diri ang part. Okay? And since they are thrown at the same time, so therefore, mo-meet na sila at the same time. So, the time for both stones are equal to each other. So the first thing that we should do here is we are going to come up an equation that relates these two parameters, time and displacement. So let's start by analyzing or by getting at least one kinematic equation for these two stones. So starting with the first stone, okay? First kabato. For the first stone, So we're going to use the second kinematic equation because the second kinematic equation relates time with the displacement. Okay, remember, sa ato ang kuan, we have delta y1 is equal to, so v naught 1 for the first stone, and then t, that is the time for the two stones, no? They have the same time. Then, since the direction of motion here is upwards, and then the direction of gravity is downward, so negative ato ibutang. So minus 1/2 g t square. Okay? And then, since given ng v naught, so ato na lang pang substitute, no, daan. So we have 50 t minus 1/2 the acceleration due to gravity that we're going to use. So since ang mga given ka in feet per second, so use the English one, 32.2 feet per second t square. So delta y1 equals 50 t minus 16.1 t square. So this is our first equation. Now for the second stone, okay, second stone, still use the second kinematic equation. So delta y2 is equals to v naught 2 t minus 1/2. So minus gihapon kay the direction of motion is opposite to the Earth's gravity. So 1/2 g t square. So here, delta y2 equals v naught 2 is 75. So 75 t minus 1/2 32.2 feet per second square t square. So simplifying, we have 75 t minus 16.1 t square. So this is our second equation. Now, if we're going to analyze the figure, no, from the figure, we can say that the height, no, delta y2 is equal to the height of the tower, 100 feet, okay, plus the displacement of the first stone. So plus delta y1. Okay? In this manner, we can eliminate one of the unknowns, no? Okay, one of the unknowns or two of the unknowns there, because we have three unknowns here. That is the displacement of the first stone, the displacement of the second stone, and the time. Okay, since we have y1 in terms of time and also y2 in terms of time, so we're going to substitute that one. So we have 75 t minus 16.1 t equals 100 plus this is 50 t minus 16.1 t square. Okay, I forgot to put here t square. Now, makancel na siya kay same matlag values. And then solving for t, so we have 75 t minus 50 t equals 100. So that is 25 t equals 100. So divide that one by 100, we have t equals 4. Okay, 4 second. Bali, mag-abot sila in 4 seconds. Okay, after 4 seconds from the time that they were thrown. So next is we're going to solve for the height because we already know the time, no? This is the first answer. So when kano sa sila mag-abot? 4 seconds after each of them are thrown, no? Is thrown upward. So number 4, solving for kuan. Solving for delta y2. So sir, nga ano mang delta y2 man ang required because that is at the same height from the ground. So the reference datum here, or I mean the datum or the reference line here or the reference frame here is the ground. So use y2 instead of y1 because the reference of y1 is the top of the tower. So use y2. Y2 equals 75t minus 16.1 t square. Okay, so 75 times 4 minus 16.1 times 4 square. So we have delta y2. Ito gamitin na to ang calculator. So we have 75 times 4 minus 16.1 times 4 square. So we have 42.4. So 42.4 feet. So that is the height of the second stone, or mapo na siyang height from the ground, wherein the second stone meets the first stone. Now, does our final answer matches our assumption? What do you think, class? Ni match ba? Yes, sa man ni match ba? Like, does the meeting point of these two stones is located at the top of the tower or at the bottom of the tower di ay? Unsa man? No, this is already the final answer. No? Delta y2, this is already the true height of the second stone. So, what do you think based on the picture lang, no? Our answer is 42, only 42.4 feet. So, ni match ba siya sa to drawing or wala? Sige nga naman. Okay. So, therefore, asa lang nag-meet sila? Is it above the tower or below the tower? Okay, so below the tower din siya. Meaning, in 4 seconds, no, what happens is, syempre, taas kaya ang tower. So, what happens that in a real scenario is that the first stone reaches its maximum height, then it drop. And at the same time, no, ni saka pod si second stone. So, dira sila nag-meet. Okay? It's okay to assume no nga at the top sila. Okay? Since our kinematic equation works, no, works very efficient as long as uh, you kanang imo gi-initialize ang tanang mga parameters based on their true direction, no? Kay kung masayop ikag butag mga signs diri then that is not the time nga mulahi pod ang imong final answer. Again, do not forget the direction of the motion and also its acceleration due to gravity. So if it is against the acceleration due to gravity, so negative gid na imong acceleration imong g. But if it follows along the direction of the gravity, then that is not the time that your the sign of your acceleration due to gravity nga g should be plus or positive. Okay? So diri okay ra jud nga masukuhay imong assumption sa imong final answer. So bali nag-abot sila not above the tower but below the tower. Okay? So yan na. Siyempre, kay first assumption naman ano mo. So subject for verification paghihapon na siya. So it's not a big deal, and it's not a problem. Okay? Naabay pangutana ani so far? So the main challenge here is to select, no, one of the three kinematic equations. It's because we have three possible kinematic equations, no? Basig mo gamit mo sa first, you can still use the first one or the third one, no? The difference is it will take you much longer time to solve the final answer, okay, or to come up the final answer if you're going to use the two remaining kinematic equations. So to make your solution short, select one of the three kinematic equations that will give you uh, those parameters nga imuhang gusto. So diri we only want an equation that contains both the time and the displacement, and that is the second kinematic equation. Okay, so manay challenge ninyo. So anay pangutana gid ani yung sabtan ra. Okay, so next. Okay, wala ra. Okay, bright good. So number 2, the second problem, still free falling motion. A stone daw is thrown vertically upward and returns to earth in 10 seconds. What was its initial velocity and how high did it go? In the previous problem, um, we are given um, a lot of values for for the parameters, no, that we need. But here, the only given here is the time, and then what's worst is we are to find two unknowns. So the first is initial velocity and how high that is the displacement, okay, or the maximum height. Now, can we answer this kind of problem? Is it possible? Kaha. So atola lista ang mga parameters na involved. First is time. This is given. Now we are tasked to find the initial velocity, so v naught, and also the displacement, so that is delta y. Okay, so let's um, choose a kinematic equation that contains either time and initial velocity, or uh, time and displacement. Okay, so I have here a figure. So this is a stone. Then again, since the size of the stone is very small compared to its path, let's assume that this stone is just a particle. So for my picture, ako na siya gi-exaggerate iya size. So first is from the ground, of course, it travels upward, no? So it travels upward, and it has, of course, initial velocity, but this one is unknown. And then next, as it reaches its maximum height, sa talaibutan, this is delta y m. M represents maximum height. As it reaches at the top or at the maximum height, of course, we all know that the velocity here is 0, or let's call this one as the final velocity. And then as it reaches its maximum height, due to the influence of the Earth's gravity, of course, it will pull this stone back towards the Earth's surface. So mo fall na pod siya and then reaches its velocity at the ground, which is negative of the initial velocity. Okay, so bali, we have kanang two scenarios here. The first one is the motion of the stone as it goes upward, And then the second is the motion of the stone as it goes downward. Okay. So let's try to come up an equation, no, per scenario. So the first scenario is going upwards. Okay, padung siya taas. Now, remember, we have three possible kinematic equations. So, mo ni ang challenge, ano, ang pagpili sa pinaka-efficient na equation. So, let's try to pick a kinematic equation that at least relate time and initial velocity. So, what would it be? Kung inyo to gi-note, let's choose the first kinematic equation. So, that is final velocity is equal to the initial velocity minus, so why minus? Because as this stone moves upward, so nagka-counteract si gravity. So therefore minus, that is g t1. So let's assume that the time going up and the time going down are different. Assume lang. So t1 ni padong babaw, t2 padong ubos. So t1. Now, since at the maximum height, the final velocity is 0, so 0 ni siya. Therefore, our initial velocity is just equal to g times t1. Okay? G-transfer na siya. Now, we already have our first equation. On the second scenario, that is going downwards, okay? So, you can still use the same kinematic equation, no? Sa going upwards. So, kuan gihapon? Final velocity. Now, the final velocity here is negative, okay? The final velocity here is negative. However, due to the fact that the direction of our motion is downward, no, downward naman, and also g is downward. So our final velocity, ang direction niya is pangadto man. So therefore, it matches the direction of our motion. So no need to put negative. Ma-negative lang na siya if ang assumptions atong direction of motion is opposite. But since the motion is very obvious nga pa downward, so therefore, take the positive value for its velocity here. Okay? Again, basig nagliw pang uban, why is it nga same man silang magnitude, sir, sa pagbatak o pagpauli niya? That is one of the characteristics of a free falling object, wherein if we are going to neglect, no, if we're going to neglect air resistance, friction, or other external forces, then the kinetic energy is conserved. Bali mo balik ra gyapon siya sa iyang initial nga velocity. Okay, so again ha, since ang direction sa atong motion is the same sa direction sa Earth's gravity, so we take the positive value for our final velocity, and that is v naught. Again, ang ato aning point of interest is from the top, no? Let's say from the top is 0.2, the bottom is 0.1. So from 2 to 1 ato ang motion yani. So the final is not 2 but 1 diri ah. So that is v naught is equals to the initial here is the v at the top. So v, now this time since ang direction sa atong motion kay the same sa g, so plus na dira, plus g, and the time here ato man siya gi let as t2. Again, v here is 0 na pud kinaman na siya sa top. So therefore v naught is equal to g t2. Now, if we're going to relate these two equations, no, v naught v naught, so we can say that gt1 equals gt2. So therefore, in a free falling object, no, in this case, t1 is equals to t2. Meaning, same lang ang time it takes for an object to to travel from the ground to its maximum height and back to its original position. Okay, T1 equals T2. Now, since we're given the total time, no? So, total time of travel or the time of flight from the ground to maximum height, padung pauli. So, that is, no? That is T1 plus T2 is equal to 10 seconds. Kaya ingat man siya, stone is thrown vertically upwards and returns to earth in 10 seconds. So, equate nimo. Wherein our T1 is equal to initial velocity over g. Then our T2 here is also initial velocity over g. So therefore, is substitute. So V naught over g plus V naught over g equals 10 seconds. Ano to lang i-ignore ng seconds nila. Now, factor out V naught. So that is 1 over g plus 1 over g equals 10. So that would be V naught times 2 over g equals 10. Now we can multiply both sides by g over 2. Okay, g over 2. So we have V naught equals that is 10 g divided by 2. So that is 10 times, since the possible either ay makuhaan is either SI unit or English unit. So let's have SI lang 9.81. Okay, you can have 32.2. Okay, all over 2. So the result here is in meter per second. So the possible answer niyan kanang in metric or in English. So let's have the metric. So we have 49.05. So 49.05. This is meter per second. Mo na siya ang first answer. The second answer is the maximum height. No? For the maximum height, use the second kinematic equation, or you can also use the third kinematic equation. So diri ata sa next slide. For max height, no? Maximum height, that is delta ym. You can use either the second or the third. Ako lang gamiton ang third. So we have, let's say, ang ato adria is going upward lang, at least going upward. So that is from 1 to 2. So we have initial velocity here. We have final velocity, which is equal to 0 kay maximum height man. So we have V final square equals V initial square minus, so y minus kay ang direction of travel is upward, ang g nato kay pa downward. So minus 2g delta y max. So again, velocity at the top 0. So ato i-transpose on the other side, we have 2g delta y max equals v naught squared. So delta y max is equal to v naught squared all over 2g. So atong V naught kay nakuha na nato, that is 49.05 meter per second. So we have 49.05 meter per second square divided by 2 times 9.81 meter per second square. So makancel na, cancel ang usa. So meter na lang gid ang magawas dira. So delta y max is equal to this one. So we have answer lang nako, no, square kay na restore man to. So na times 9.81. Our final answer is 122.625 122.625 meters. So this is the maximum height that can be reached by this stone. Okay, do you have any question? Naipangutana? Okay. Diri sa previous. Sige. How about the others? Ay, kawaw. Pangutana sa kutob sa malibog. Okay, I think nine chat. Kay basig mga utana ranig dito na kusog na mga utana kung ting comply na. Okay, wala man di ay. Okay, sige. Oh, yes. Oh, dili. That's V. That's the velocity at the top. Ang kaning V. It's because ang initial velocity if going downward na ta is ang velocity at the top which is still zero. Na. Oh, kay going downwards ta ang ato ang analysis ani is from 2 to 1. Whereas going upwards that is from 1 to 2. Akong gilabel din na. 1, 2. So mana siya. Maong na 0 na siya. Okay. How about the others? Okay, wala na. Sige. Let's have our final example. Our final example, this is not free fall, but this is application for a straight line motion. And this one, I included this one because it came out during our board examination. No? So, kana siya. Wa giusab ang mga given, maora gid gihapon. So, na-memorize na rin ako, ano na ako sulba kay kaagi naman ko ani. So, maora gid akong kaning reference kaning kang singer. So, ang answer ani kay di ko na makalimtan, that is 60 miles per hour. But in this example, I mean during my board examination, wala ni gi-include ning kaning additional nga kanang question kaning how long does it travel at this top speed? Kanirang what is its maximum speed in miles per hour? So again, this is a train. So this is our particle, no? Train. Gi-assume lang the dimension of the train is very small compared to its path. No, kay in miles na guna siya. Okay, always note that a mile is greater than a kilometer. Okay, so a train travels between two stations wherein the distance between this station is 0.5 miles apart with a minimum time of 41 seconds. So 41 seconds lang ang total time of travel niya. Now let's have its illustration no, para masabtan. So ang first station is located at point A. The second station or the destination of the train is point D kana siya. So initial velocity represented by V naught. Final velocity ngadto na sa ikaduha nga station represented by V lang. Okay. Now ato na siya i-dissect ang iyahang motion. So ingon siya diri if the train accelerates and decelerates. So naay duha ka scenario ni accelerate si train meaning mikusog siya dagan, no? So pasabot ana ang pagkusog og dagan, that is its velocity increases. And then second scenario, it decelerates, no? Meaning nipahina ya dagan. So its velocity decreases at a rate of 8 feet per second square. Okay. Starting from rest at the first station and coming to a stop at the second station. So meaning initial velocity 0, final velocity 0. Now, at first no, libog ni siya i-solve if wala ni siyang additional nga question. Kay mag-assume ang tao nga as it reaches its top speed, or ako lagi butan di maximum Vm, so nikalit din siya og brake, no? Top speed, brake. So bali na involved lang nga scenario is duha, acceleration and acceleration. However, you cannot solve this problem if duha lang ka scenario. That is why this problem, no, you should need this additional question. How long does it travel at this top speed? With this question, no, nanay intuition ang student nga as it reach its top speed or maximum speed, no, it will take for some time, no, to stay in this particular velocity, no. So napada siya ay third scenario, meaning in the first scenario from A to B ni accelerate siya mao nang A na dira positive. Okay? Naa siya time ni ana, na po siya displacement. Now, as it reaches its top speed, no? Na pa siya time nga ni stay ni ana nga speed. So meaning acceleration here is 0. So we don't have acceleration. That is why walay A din nakabutang. So meaning constant velocity. Now, at some point in time, no, ni decelerate siya. So bali ni ubos iya velocity until ni stop siya. So here ako gibutang negative A pasabot sa negative sign for acceleration, that is deceleration, meaning nihina iya velocity. So we have three scenarios. First, this one. Second, this one. And the third, this one. So for every scenarios, we are going to get at least one kinematic equation. So daghay given ani, no? Daghay given, lisod kaayo mamili og mga kinematic equations. So ang imo buhaton is that imo ilista ang mga parameters nga naa, no? So first, kinahanglan ta og displacement, and then manginahanglan po tag relation sa displacement with respect to time for every scenario, and of course the acceleration, at least kana. So since na may displacement, no, you can choose either kinematic equation number 2 or number 3. However, kung imo kitaon, ang 3 wala man siya time, no, wala siya time ana. So therefore, choose number 2. Okay? So use kinematic equation number 2 for each of these scenarios. So let's have the first scenario. That is from point A to point B, wherein we have an acceleration. So using the second kinematic equation, we have x1, the displacement, equal v naught t1 plus, so y plus kay acceleration and direction sa acceleration is equal sa direction of motion. So plus 1/2 a t1 square. Now, since ang initial velocity kay 0, so ma-0 ni, mo may state sa problem. So x1 is equal to 1/2 acceleration t1 square. Now, let's proceed to the second scenario. So kindly take note this one, kay taas-taas ni hang process. It would take us 2 slides siguro or 3 slides. Now, from the second scenario, that is from B to C, we don't have acceleration here, so acceleration is 0. So use second kinematic equation, so that is x sub 2. I mean, this one, okay, this one, we are not using the 3 kinematic equation because sa 3 kinematic equation, ang ato acceleration dira kay not equal to 0. But, I mean, pwede gud ta di mo gamit, no? Mobalik ta sa basic definition for velocity. But, pwede po ta makagamit. Sige, ato lang gamiton, ato lang ilet nga 0. Kay constant man. 0 is still constant. Sige, para di maglibog. So, x sub 2 equals this is not v naught na, no? Top speed naman din eh. So, this is Vm, this is T2 plus 1 half A T2 square. Since A equals 0, so mas 0 na siya. Therefore, x sub 2 is equals to Vm T2. Okay? Vm T2. Next. Sa third nga scenario, okay, from C to D, we have deceleration. So, bali, nihina iya velocity. So, we have x3 equals, that is the initial velocity from C to D is the top speed, no? So, we have Vm T3. Now, since that is deceleration, bali ang kuan ani is negative, so we have minus 1 half A T3 square. Okay, direction sa acceleration na pabali na. Okay, meaning kaning acceleration ipugong siya sa motion sa ato ang train. That is why I put here negative A. So diri wala makancel ani no kay naman yung mga value sa mga top speed and also the acceleration. Now next is we're going to combine this equation, no? We're going to combine all the displacements because the total displacement is given 0.5 miles, so that is x sub 1 plus x sub 2 plus x sub 3 equals the total distance of these two stations. That is 0.5 miles. And para coherent ang ato ang mga units, since this is mile, no? Kunya ang atong mga G kay 32.2 feet per second man. So we're going to convert miles into foot. So unsa may conversion? Namoy na kuanan nga conversion from miles to feet. Sige, kinsa may nakainomdom? Conversion sa miles to foot or feet. Wala idea? Napa mo? Okay, 5,280. So that is 1 mile, 5,280 feet. So cancel out. So the resulting value here is 2,640. Okay, 2,640 feet. So nga lang ta sa next slide, no? Ato ni ipang substitute ang expression for x sub 1, x sub 2, and x sub 3 in terms of the top speed, the different times for different scenarios, and also the acceleration. Okay, so again, ato isuwat, no? We have x1 plus x2 plus x3 equals going back to 640. So 2,640. Now our x sub 1 from the previous slide, that is 1 half a t1 squared. So 1 half a t1 squared plus our x sub 2, vm t2. So vm t2 plus x sub 3, kani, vm t3 minus 1 half a t3 squared. So vm t3 minus 1 half a t3 squared equals 2,640. Now, daghan kaayo mga unknowns ani. However, naay mag-equal ani nga mga unknowns, no? But, sa ato ibutang ang una, T1 is equals to T3. Nganong mang equal na sila, sir? It's because if you analyze the first scenario and the third scenario, okay, there they have the same value for its acceleration. No, they only differ on the sign. In the first scenario, it accelerates. No, the second scenario, still it accelerates but pagamay. No, same value gihapon. So we term that one as deceleration. And another thing is they have the same velocity before. I mean, the velocity of the first scenario before and the velocity of the third scenario after are the same. So mura sila nag mirror effect, no? Kay ang final velocity pod sa scenario number 1 and the initial velocity of scenario number 3 are both the same, no? Vm, top speed. Okay? So pwede pod, no, nga moingon ka og same po na sila og x sub 1 ug x sub 3, sir. Di ta ka sure ana, it's because, I mean, yes, maka-sure dita ana, it's because same day sila og time. So therefore, x sub 1 is equals to kuan x sub 3. So if tanan parameters equal, no, sa kana nga scenario ato pag-analyze, then sakto pud ni nga ang time nila equal pud. So t1 is equal to t3. Therefore, mahimo na siya og 1/2 a t1 lang atong dadon plus vm t2 plus, so Vm, ang TT diri T1, so Vm T1 minus 1/2 A T1 square equals 2640. Now, diri ta masangit aning kanino, kaning T1 is equal to T3. If diya kay ba mo analyze sa mga parameters sa kada scenario if di ba ni equal ang mga time. So, kay paraman sila og value sa acceleration. More or less, if imong kita na ang iladay mga velocities, no, kada boundaries, if ever parehara, so therefore pareha na sila og time. Okay, wala mo gud gi-state diri pinatago man nga pagka-state na imo sa analyson. Kay if ever i-ano na to T1 T3 ra, maglisod na pangitag ko ano mag run in circles na lang kaniani. So here natay ma-cancel kani siya. Ma-cancel pod ni. So what's left is Vm na lang. So let's write it here. We can factor out Vm diri ano. So we have Vm times we have T2 plus T1. That is equal to 2640. Now, nasabtay koan. But we all know nga, ang total time from station A to station D is 41 seconds. So, we add the 3 times here, no? Kaning T1 plus T2 plus T3. That is equal to 41 seconds, sorry. So again, we all know that T1 and T3 are the same. So ato na siya i-write as T2 plus 2 T1. That is equal to 41. So T2 di is equal to 41 minus 2 T1. And we're going to substitute that one right here. So therefore, we have Vm times 41 minus 2 T1 plus T1 equals 2640. Okay, so this is 41 ha. Pasig maglibog. Therefore, Vm is equals to 41 minus T1 na lang. Okay, is equals to 2640. Now, we still have two unknowns. No? Lisod pa kayo ni siya i-simplify. Now, let's try to find another relation for V1, top speed and the first time, kaning T1. So, I'll just insert my solution here. Okay, insert. So, balik ta sa first nga scenario, no? So, first scenario. This one. Kaning from station A to, this is not station, no? But position ni from station A to position B. Now we're going to look a kinematic equation that relates the top speed and T1. So we can use the first kinematic equation. Now we're in the final velocity. The final velocity for the first scenario is the top speed. So Vm is equals to the initial velocity, which is V naught, plus acceleration tapos T1. Okay, na natay relation nila. And V naught is 0, okay? Starts from rest man. So therefore, Vm die can be expressed as acceleration times T1. Okay, so diri ato na substitute. So we have AT1 times 41 minus T1 equals 2640. Now let's continue this one on the next slide. So on the next slide, again, AT1 times 41 minus T1 equals to 640. So you multiply, we have 41 AT1 minus AT1 square equals 2640. So transposing this one on the other side and also to the other side in order to create a quadratic equation. So quadratic equation is siya because the degree is 2. So we have AT1 square minus 41 AT1 plus 2640 equal 0. Next, substitute the values for acceleration. So given matag acceleration, no, our A here is 8 feet per second square. So substitute ang A. So we have 8 T1 square minus 41 times 8 T1 plus 2640 equal 0. So that is 8 T1 square minus this is 328 T1 plus 2640 equal 0. So this is a quadratic equation, so we can use our cycle. So press AC, go to mode, press equation 5, press 3 sa quadratic. So first coefficient 8, second negative 3 to 8. Third is positive 2, 640. So natin mga roots diri 30 and 11. So we have T1, the first root. We have 30 second. Ang second root niya is 11 second. Again, lisod pilion kay both roots are positive. Okay, both roots are positive. But let's try to confirm this one sa ato ang expression nga, no? From the expression or from the equation, I mean. From the equation, the previous slide about time, kani siya, just this relation. So we have T2 equals 41 minus 2 T1. Now, if we're going to use 30, no? At 30, T2 is equals to, actually, ang result ani is negative. Okay? The result here is negative. So, mode compute, 41 minus twice of 30. So, negative 19. Now, nabay time nga negative? Wala. Di po ni siya time machine ha. Lahi ng negative. Walay null ni siya. So, this is null. Now, for at 11, so what would be T2? That is 41 minus 22. Pila may 41 minus 22? 19. So, the positive 1. Okay, so muna siya to ang E. Gamit ang positive. So, use 11. So, therefore, the first nga unknown, I mean, ang first nga requirement kay ang maximum or on top speed. So we already have Vm is equals to, that is acceleration times T1. So that is acceleration times T1. And that is, our acceleration is 8 feet per second square. Our T1, choose mo na itong 11 seconds, so times 11. So that is 88 feet per second. But that is in miles per hour. So matong kuan kaganiha nga di na ko makalintang answer nga 60. Now ato i-prove kung 60 ba gid ni. So convert. So again, 5,280 feet, that is 1 mile. How about second to hour? So na direct, no? We have 3,600 seconds, that is 1 hour. Okay, cancel lang feet, cancel seconds. So our top speed for this train, so we have 88 times 3,600 divided by 5,280. So the answer is 60, exactly 60. So 60 miles per hour. Okay, di gini malimtan. Ani memorize, kailangan pud kay bawa ka sa pamaagi sa pag-solve. Next is, how long does it travel at this top speed? So it talks about the time, no, at the second scenario, kaning time from B to C. So solving for T2, okay ba nata kani? T2 is 19, no? T2 equals 41 minus 2T1. Ako lang isuwat 3 41 minus 2 times 11. So that is 19 seconds. Okay? So meaning, ni-stay siya at a top speed of 60 miles per hour, no? In 19 seconds. And after 19 seconds, ang remaining niya nga 11 seconds, ang pag-decelerate niya. Okay? I-put mo into kanang real scenario. Grabe kini nga train, no? For 30 seconds, for 11 seconds, na-achieve niya ang top speed niya. So, grabe kayo kuha siya nga train. Unya, nakaabot din siya sa ikaduha nga station, but of course, half a mile naman sad. So, duol-dulo na in terms of the train. So, ni stay siya sa top speed for 19 seconds, and then afterwards, ni-apply siguro na siya og brake. So, ni-decelerate siya at 8 feet per second. So, mao nang naka-stop gid siya in half a mile. Okay? So, any question regarding ani? Okay, ako na lang i-end ni, no?